Assalamualaikum and hello to all. Today we are going to proceed to chapter 6.3, preparation of carbonyl compound. Okay, learning outcome at the end of the lesson, you should be able to explain how to prepare carbonyl compound, which is aldehyde and ketone, through the process what we call oxidation of alcohol. Okay, oxidation of alcohol. So we can prepare aldehyde if we are using primary alcohol. Okay, so primary alcohol given for you here, primary alcohol can be oxidized to give aldehyde using PCC. Okay, PCC is a mild oxidation reagent. Mild oxidation reagent. So for example here, what we have here, 1, 2, 3. So this one is actually alcohol, propanol, and this one is primary, yeah. So primary alcohol. So you react with PCC with the presence of CH2, Cl2. This is the inert solvent. So what you should get here is aldehyde, and the aldehyde that you get is, okay, let me just draw the same like that one, CH2. This one you will get COH. Okay, the carbon is still 3, yeah. 1, 2, 3. So the same with this one. 1, 2, 3. So 3 alcohol. And this alcohol, this aldehyde that you get is actually 1, 2, 3. Propanol. So propanol, you will get propanol. Okay. If you have 4 carbon atom, for example, 4 carbon atom, CH3, CH2, CH2, CH2OH. Okay, react with the same reagent, PCC, CH2, and Cl2. You will see this part will become the carbonyl group. Okay, so CH3, CH2, CH2, and for this one you can draw like this, aldehyde. Okay, so this one for carbon atom it is butanol, and for this one it is 4 carbon atom for aldehyde, so it will become butanol. Okay, so that is how you are going to prepare aldehyde using primary alcohol. Okay, next one, you want to prepare ketone, and you need to use secondary alcohol. Okay, secondary alcohol. Okay, so secondary alcohol can be oxidized. You can oxidize secondary alcohol to form ketone, which cannot be further oxidized. Means that you are going to use strong oxidizing agent. So this one, you can use either KMnO4, acidic H+, the symbol delta here refers to hot, and potassium dichromate, acidic and also hot. Or sometimes it is also written like this. Okay, sometimes also written like this. This is actually the same, equivalent. These two is equivalent. Okay, so let's see. Aldehyde, ketone. What is ketone? Ketone, you should remember that it will form a structure like this. Okay, this is the carbonyl group. This is alkyl group. This is also alkyl group. So how many carbon here? 1, 2, 3, 4. So this one is actually 2 butanol. Okay, 2 butanol, because this one is secondary alcohol. So react with K2Cr2O7H+ with the presence of heat. So what you get is actually carbonyl compound, CH2 and CH3. So 1, 2, 3, 4. So this one is actually butanol. Butanol. Sometimes we have the tendency to label this one 2-butanol, but for butanol, there are no other ketone with 4 carbon atom that is 2-butanol. It can only be 2-butanol. Okay, it cannot be 3-butanol. If you put the carbonyl at this part, okay, at carbon number 3, actually the longest, the nearest to the chain is actually 2. So it still always be 2-butanol. Okay, so let me erase this one first. Okay, so you can see that this is butanol. Okay, what about cyclic compound? Okay, if you have cyclic compound, For example, this one. This one also secondary. Yeah, you need to remember that this one is secondary for you to form ketone. So this one easy. So you just change the OH group to become carbonyl group. Okay, so this one it will become cyclohexanone. This one is actually cyclohexanone. Okay. If you have, let's say something like this, cyclobutanol, okay, react with oxidizing agent, strong oxidizing agent KMNO4 H plus with the presence of heat. The same thing, you will see that the carbonyl group will be formed at this part, and this one will be cyclobutanol, whereby this alcohol is actually cyclobutanol. Okay, so that is the preparation of the aldehyde and ketone, how to form carbonic compound. Okay, so that's it. Short video. Good luck. Bye.